Tonight is June 17, 2016, and this is the Acrosound stereo amplifier that I mentioned in one of my other videos that I am going to build. I haven't started drilling any holes yet. Been playing with the layout. Thought I'd get you guys' thoughts on it. I've got the perfect transformer right here. Let me see if I can show you this thing. Hopefully not drop it. Hopefully that'll focus on it. It is 700 volts center tap, 200 mils. It's got a 6 volt 8 amp winding. I won't be using the 5 volt winding. It's that's cat's meow for the power transformer. Has to sit right there. If I get a chance tonight in this video, I'll show you that I use the FFT software to measure which orientation was best, and this is the best, about whether to put it this way or that way, and you know, and even each way to turn the transformers to get the least amount of hum that would be induced into the output transformers from the power transformer. It'll be very traditional. 6SL7, 6SN7 drives this pair. Same here, 6SL, 6SN drives this pair. I do have a bunch of these red base ones. See, this is a Jan 5691. That's a 6SL7 that I'll be using. 5881s. It's going to be strictly an Acrosound design. I'm not going to put any of my tweaks or twists in it. Traditional to the core. Let's see, right over here on this side I'll put the inputs, probably a level adjust. Very simple. In the back, the only thing that I might and I will strengthen tradition for is I'm going to put one of these types of connectors in it. I'm not just going to have that big power cord hanging out. I don't like that anymore. I've got this kind, which is the dirt simple one. Got some here with a little bit of capacitors in it to ground. I think I probably, well, let's see, I can choose whether, I don't know if I can choose it or not. I'll have to look at that. I think it's got capacitors and a coil built into it. I'll see. And there's, of course, this kind. Has a fuse over here. I might use that, but you know, this cheap computer junk stuff, I don't know. I don't have a lot of confidence in it. And then here's the last one. That one would actually give me the switch. But I think I'm probably going to go very simple with this kind and a fuse and a little slide switch. I do want a AC on off. I have some nice little touch-up things like this that's come off of some old General Radio stuff that I've partied out. See, one side says 115 volts, 40 to 60 hertz. The other side says 230. So, you know, I harvest this kind of stuff off of the amplifiers all the time. I don't have enough of these things that I wish I did. Can you see that says 6SL7? If I had two of these, two 6SNs, 45881s, I would love it. But I don't have that. I've tried to make copies of the Acrosound. This is just paper. This was just a scan and a print. But it's the wrong size, so I'm not sure if I'm going to do that or not, because if you look down at the tops of the transformers, you see they're kind of washed out. They're not real pretty. Get the glare off of it. But it is what it is. Now, here's one of the variables, and I'm open to thoughts, what you might think about this. Always welcome you guys' thoughts. I've learned as much from you guys as you have from me in many cases, because I just don't think about it. Let me crank the camera up here a bit so I get more of a look down picture. Get up a little closer. And what I'm thinking about, this layout right here is pretty much like something from, say, an old Macintosh MC275. But there are some variations to it. And I've been tinkering with it. What about this? For one channel. and the drivers. And what about this? Yeah, this would be the other side, 6SL, 6SN. You know, the exact orientation of the socket and all would be debatable. I don't think there's anything right or wrong about any of it. This would concentrate all the heat in one spot and mostly dump it into the, you know, mostly radiate it, I should say, into the power transformer. I think the heat would be distributed better the other way. And of course, this is a possibility too. I like it. I like that. Actually, I like them all. I just can't decide. Not sure what I'm going to do here. This right here, I kind of like this because, well, I don't know, it just seems to be so nice and clean. What makes this work is there's some physical symmetry to it, because this tube drives both, and there's just some physical layout that makes that dandy right there. That's actually pretty appealing. I don't know. Well, that's my quandary at the moment. It's good to have such trivial quandaries, huh? And not being shot at by terrorists. At least not here in El Paso yet. Anywho, that's probably what I'm going to go with right there. This thing will probably do about 20 watts of really top notch. I figure it'll go down to 10 hertz at 15 or 20 watts. I'm believing that it will. For one reason, because I know that these transformers have quite a reputation, and I checked a number of years ago. A gentleman brought an Acrosound amplifier, homebrew, to me. It was not him that built it, but someone else. I don't know who built it. Quite a long time ago. It had a pair of 807s in it, and when I put that thing on and tested it, I didn't have all the test equipment I have now, but I was like, wow, this thing, these transformers are for real. So anyway, that's that. That's the beginning. I'll start drilling holes, and once I really get rolling, it probably won't take me more than a week. These are all used sockets. I think that they're the best. A lot of the tube sockets that we can buy today are trash. I think all you guys that mess with this stuff know that. These are old vintage military surplus stuff that I've harvested out of equipment over the 50 years I've been doing this hobby, 50 plus years. I will not be using any vintage capacitors or resistors. That's a bad idea. I've made a couple of written comments in the YouTube postings about some equipment I have, and I built a pair of 4-400 for a RF amplifier way back, oh, I don't know, 1975 or so, and I kept it for some time, and then I built that 4CX1000 amp in 1983, and so I swapped it out. But one of the capacitors that is in it came out of World War II stuff. So in 1980 it was about 35 years old, and it was good. And of course that was 35 years ago, so now that capacitor is 70 years old and it's no good. It opened up. I'm seeing a lot of open capacitors. I wish I had drag one out of here, but I can't find it. But speaking of open capacitors, this C20 amp, C20 Macintosh preamp right here had an open capacitor in its filament supply. It was a 1000 microfarad, oh, I don't know, 16 volt or something like that, you know, for the 12 volt filament. And by replacing it, I didn't make a video of it, but by replacing it, it just got immensely better. 20 dB or so. I don't remember the exact numbers. And I did make a video on this guy up here, and that thing is just beautiful. I just love it. Anyway, that's what I listen to. Well, that's all I can think of right now, and I'll keep it short. And there you go. Always open to constructive thoughts and criticism, so there you go. Stay safe. Okay, for this next setup, I'm going to show you what I'm going to be doing, and then I will I'll zoom the camera in just on the program over here. But you see what I've got? It's a transformer right here, and I'm monitoring across the full secondary. So I'm trying to make it as sensitive as I can, you know, so that I got the most amount of winding, so I'll pick up the most amount of hum, so I'll be able to compare it. So here I'm looking across one switch, a plate lead and a plate lead. Here are the ultra-linear string taps. Here's the center tap, and here's the 4/8 ground 4/8/16 on this side. And this is the power transformer I'm going to be using. So what I'm going to do is plug it in. I'm going to move the camera over here so you can see this, and I'm going to turn. I'm going to leave this one sitting stationary because I will have 700 volts coming out here, and I don't want to get across that. I'm going to move this thing up here like this, and we'll look at it, and I'll turn it, and turn it, and I'll move it over here to the end and do the same thing. And I'll show you some pretty amazing stuff, okay? First of all, I'm going to plug it in. Got all this stuff insulated. I don't have my 700 insulated. I don't have a load across it, and I'll put a load across it and show you the difference too. Here I've got a 1 ohm resistor, and if I put a 1 ohm resistor across the 6 volt winding, I'll be drawing 6 amps. So I'll be loading this thing heavily, and I'll be explaining it, but we'll be watching this. So let's zoom in on this guy and watch what happens. We don't care about THD. That's meaningless. I'm going to plug the transformer in. Okay, so I'm going to jump a little bit. I probably don't need as many bends down here. I've got this set at 131K. But see, right now, our 60 hertz, which is what we're interested in, these are the harmonics of it. So we're not dealing with a power supply, as some of these mistakes I've made in some of my other videos. We're dealing strictly with 60 hertz. So we'll just watch this one. This one's down about 48 dB. Now I'm going to turn the transformer 90 degrees. See? Now it's down at about 39 dB. It went up almost 10 dB. I'm just going to keep turning it clockwise. There it is again. It went back down to about the minus 48 to 50. Now I'll turn it clockwise one more time. Went way back up. Okay, wait a minute. There's my little output lead shorting. That's okay. No high voltage there. See, way up about minus 35. That's awful. And the last turn there, which I may have already done, is back down at about 45. Okay? Now, just to show you what I'm going to do, then I'll go right back over there. See, that's the way I've oriented it. Now I'm going to move the transformer around here to the end and do the same thing. And we'll see the difference. Okay, that one is at about minus 55. Okay, I'm going to rotate it clockwise. There it's about minus 48. There it's about, oh, see, I went at least down to minus 60. Right there. And there again, we're back up to minus 50. So it's interesting. See, it goes back down to the minus 60. So it's interesting that, let's see, from this side, and then I'll put the, let me see, okay. I don't know if you can see all this at once, but it'd be nice if you could. Probably can't. Let's get as close as we can there. Okay, see, with this transformer oriented this way, we're down at about minus 60, but I'm going to do 180. So you might think that this side or this side would be exactly the same. Minus 60, and then this one is, so it went up about, I'd call it minus 53, went up like 7 dB from that side. Let's see, can you see all that? Yeah, I think you can. From that side to that side. So it matters a lot, and you can't just throw it in there. And it might even matter if I put it on the other end a little bit. I will be testing all that and deciding which is the best orientation. But just deciding, well, I'll put it toward the end with no regard to how the output transformer is oriented, believing that the left side is the same as the right side. Let's see. Well, no, see? Let's see. From this side, it is best. Let's see, is it best right there? No, it's best right here. No, it's best right there, right. So you see it'd be best if this one was on, see it's this side right here toward the transformer that's best, right there. Anyway, that's something I will have to determine very tediously. Now, will we actually be able to hear that hum coming out? I don't know, for sure. But I know I want to do it the best I can. And I know I just keep praising these little programs, but when you can see signal levels down at minus 100 dB so easily, minus 110, even 120. Now, this thing says the noise floor is somewhere down here at about minus 130. Well, being a conservative here, I'd say I would put it at 120 and know it's at least that good. But isn't that neat? Trying to do it right. Hope you enjoy.